Today, much of the value we generate is based on intellectual capital, as opposed to financial or material capital. The important role of intellectual capital is why today's economy is known as the knowledge economy. The problem with the knowledge economy is that much of this created value is intangible, hard to measure, and hard to capture in a form that's both durable and shareable. There are great opportunities waiting for those who can figure out how to transform knowledge from an intangible asset to a tangible asset. Understanding the shape of knowledge is key to doing this. In order to make knowledge tangible, by capturing and storing it in a durable form, we first have to understand what knowledge really is. My belief is that knowledge is structured information. What do I mean by that? This common drawing represents a hierarchy of understanding. It's a pyramid that shows data on the bottom level, information as the next level, then knowledge is an even higher level, and ultimately wisdom is at the pinnacle of understanding. This is an interesting visual. Based on the areas at each level, there's less of the higher forms of understanding than the lower forms. There's a lot of data available, but wisdom is scarce and hard to find. The lower level forms can be transformed into higher forms. For example, when I use statistics, I'm transforming data into information. But how can I transform information into knowledge? That's the question I want to discuss here today, and that I address in greater depth in my book, The Shape of Knowledge. Before we can answer this question, though, we need to realize that knowledge is a product of the human mind. And to understand it, we need to understand a little bit about how our minds work. Mentally, we break everything in our world down into things and the relationships between things. We look around us, we see many things, a chair, a table, a book, a lamp. We navigate through our world by understanding the relationships between things. The chair is next to the table, the book is on the table, the book is under the lamp. All of these relationships, next to, on, under, are the same type. They're spatial relationships. Some of our things are physical things, like the chair and the book, and some are non-physical things, abstract concepts, like events. We can talk about the relationships between events. For example, I can say that the Titanic sank before I was born, and I got my first job after I graduated from college. In these cases, both before and after are another type of relationship. They're temporal relationships. I like to think about thinking as a connect-the-dots game. The things we think about are like the dots in the game. Relationships are like the lines. They're the connections. And when we make the connections, we create structure. If we connect the dots correctly, a shape will appear. In this case, we're halfway to drawing a cat. So what does this have to do with information and knowledge? I think information is like the dots in the connect the dots game. And when we make connections between many discrete pieces of information, we create knowledge. Information is transformed into knowledge by providing the right structure. Just as we need to connect the dots in the right order to make the cat appear, we need to apply the right structure to generate knowledge that is useful for solving problems. The shape of knowledge is about how you decide what that structure or shape should be. I said at the beginning that today's challenge is how to make knowledge tangible, how to capture it in such a way that it is both durable and shareable. We've learned to transmit knowledge by creating knowledge artifacts. In general, an artifact is anything made by a person to achieve a particular purpose. Thousands of years ago, Aristotle made an observation about artifacts. He said all artifacts had the same 4 inputs or components. He called them the 4 causes. He said every artifact begins with the intent or goals of the creator. Every artifact has raw materials and a form. And finally, there's a process by which the materials are actually put into the form. Intent, materials, form, process. Aristotle said all 4 are required to create a human artifact. This discussion is going to focus primarily on one of these four causes, form. Other words we can use to talk about the form of an artifact are shape and structure. To make Aristotle's framework a little clearer, let's look at a couple of examples. A house is clearly a human artifact. It's something we make to achieve a purpose. The intent that drives the creation of the house is to meet the needs of the homeowner. Such requirements as how many bedrooms are needed, the number and type of other rooms, perhaps a minimum square footage. The homeowner also has style preferences and probably has a maximum budget. The builder's intent is to meet all of these needs. The raw materials of a house are building materials like lumber, drywall, brick, and so on. The house shape or form is reflected in the house plans that are selected. The builder picks a plan that has the right number and arrangement of rooms, the right square footage, and the preferred style. Construction, then, is the process of taking the building materials and forming them into the shape that is shown in the house plans. A very different artifact is a hand-knit sweater. The knitter's intent is to please the future sweater wearer. The knitter considers the climate the sweater will be worn in, and the wearer's taste in clothing, and many other things as she selects the yarn that will be the raw materials and the pattern that describes the sweater's shape. Her skills will influence the construction method. Maybe she'll crochet the sweater instead of knitting it. Aristotle's four causes are present in both house building and sweater knitting, and they're highly interrelated with one another. The intent of the creator has a big impact on materials, form, and process selection. But it's also true that materials, form, and process are interrelated. The house plans, for example, will have a bill of materials that specifies the quantities and types of building materials necessary to build that particular house. If the sweater maker decides she'll use crocheting as her process instead of knitting, she'll probably need a different pattern. The four causes are so intertwined, it may be hard to separate them at times, but there's value in doing so because when the creative process isn't flowing right, it's easier to diagnose where the problems lie. Now let's return to knowledge artifacts. The oldest artifacts for conveying knowledge are the sounds of speech, and this oral tradition remains strong to this day. But some of the greatest transformations in our society have been driven by learning how to transmit knowledge through better and better knowledge artifacts. Cave paintings were an important addition to storytelling because they could outlast their creators. Books were an important step forward because authors could reach audiences they couldn't see face to face, in other places as well as other times. The printing press made books affordable so they could reach a much broader audience than precious illustrated manuscripts could reach. Now the internet has made written and graphic representations of knowledge even more accessible by lowering printing and distribution costs. Video and film have made it possible to capture oral storytelling and instruction in a durable and distributable form. And today we're experiencing another leap forward. We call our newest form of knowledge artifact a software application, or app. What makes apps or applications special is they do more than instruct you on knowledge. They actually apply some of that knowledge for you. That's where the word application comes from. It's the application of knowledge done by a computer or mobile device. It's the most powerful type of knowledge artifact yet. Every knowledge artifact has a shape, and structure or shape is driven by the relationships between objects or concepts. Structure arises from connecting things. The shape of a knowledge artifact is closely related to the number and type of relationships that exist in the knowledge that's being documented. Thinking about the shape is important because not all knowledge shapes are created equal. Certain shapes are much more effective for capturing certain types of knowledge, so selecting the right shape is essential for achieving your goals as a knowledge author. I'm now going to run through a brief overview of some important knowledge shapes and how they're most effectively used. This topic is covered in much more depth in my book, The Shape of Knowledge. Some of the knowledge artifacts we're most familiar with fall into the group of shapes that have axes or dimensions, and the objects or things connected by the artifact have coordinates in those dimensions. Knowledge artifacts, notifacts, with only one dimension have a line shape. Examples are timelines and lists. We saw a timeline earlier where, by declaring the position of events like my graduation and my first job, I could infer that I got my first job after I graduated. Another example is a list of instructions. If I number one instruction with a 1 and another with a 2, I can figure out that I should do step 1 before step 2. I call a 2D shape a square. Examples of square notifacts include maps, graphs, and scale drawings. When I plot a location on a map or a graph, I do it based on its x and y coordinates. When I have the coordinates for several objects, I can calculate the distance and direction from one to another. Other examples of square notifacts are data tables and spreadsheets, which are like maps but with row and column headings. And then we have cubes, which are 3D and are used in modeling systems like CAD systems and for multidimensional data storage like relational databases. In general, this group of knowledge shapes is best used for location knowledge and representation of real-world objects. Another group of shapes is characterized by the fact that the objects are connected by many-to-many explicit relationships. This type of network model is a very hot topic right now. Google talks about knowledge graphs as the technology behind their new and improved search methods. Facebook and LinkedIn are concerned with social graphs, which are based on the many connections between their members. Facebook is also working on developing interest graphs, which connect people with things they like, the end goal being to serve up better advertising to Facebook users. Another example of a network diagram is the simplified version of a road map that's composed of junctions and roads. This is the type of model that is behind a vehicle navigation system. In all of these cases, a great deal of information is stored about connections, but no specific structure emerges until some sort of processing is done on the model. One structure that emerges from the junctions and roads network is what I call a hexagon. This is where a starting and ending point are specified, and all the possible routes between them are laid out. This is done in a navigation system when the starting point is your current location provided by the GPS, and the ending point is your desired destination. The system measures all possible routes and selects the one that meets your requirements, either the fastest route or the shortest route, and one that avoids the types of roads you've said you don't want to take, like toll roads or ferries. Currently, these shapes are most often used for navigation and routing, but they're also being investigated as ways to do big data analysis. My favorite shape is the triangle. This shape is characterized by the one-to-many hierarchical relationships you find in tree diagrams. This shape is the best way to capture the knowledge associated with many different types of higher reasoning skills. For example, one important reasoning skill best documented with a tree structure is classification. A classification tree is called a taxonomy, and it's used to break classes of things down into subclasses. A famous example of a classification notifact is the Linnaean hierarchy, which classifies all living things by kingdom, phylum, class, order, family, genus, and species. Another very important reasoning skill that's best described with a tree is composition. Decomposition is the process of taking something and breaking it down into its parts, and then taking those parts and breaking them down yet again into their subparts. We do this for physical things when we create a hierarchical product model, like this decomposition model of a house. But we also do it for non-physical things, for example when we decompose processes into sub-processes and tasks. We can also decompose arguments and thought processes into their individual parts, and I call this special subset of models evaluation models. In these models, the things are logical propositions or decision criteria, and the relationships that connect them are mathematical and logical relationships. This is the legal argument for proving malpractice. When we document a complex decision using this type of model, we make it possible to execute that decision over and over again, accurately and consistently. Now, with at least an introduction to the idea of knowledge shapes, what they are, how we can talk about them, we can consider their role in knowledge sharing and some best practices for using them. Knowledge shapes play two important roles. We use them to document and store knowledge, and we use them as communication devices for sharing knowledge with others. When we write a book, the book performs both roles simultaneously. It's both the knowledge repository and the communication device. This is not true, however, for our newest NotiFacts applications. When using a navigation application, drivers never see the database behind the system. They hear the driving directions, supported by a map of the current road situation. So what are best practices when it comes to both storing and communicating knowledge? First, pick the best shape for storing the expert knowledge. If the knowledge embodies higher reasoning skills like classification and composition, some trees will probably be involved. If it involves the storage and retrieval of a lot of data, there will be data tables or relational databases. Squares are good for this because data management is fundamentally a location exercise. The next best practice introduces a new idea, which is that an expert's knowledge is often more than a user needs at a particular point in time. The expert documents what's important to know in many different situations, but the user only wants the solution for the situation they currently face. So to be really helpful to someone, the expert knowledge needs to be simplified, honed down to match the user's current context. That context is defined by the user's current goals and the current environment. In our navigation example, the goal is to go from here to my destination, and the environment includes the current traffic along that path. The fact that the system knows about roads that are not part of my current route is irrelevant. The next best practice is to deliver the solution to the user in the simplest shape possible. In the navigation example, the simplest shape is a very common shape used for communicating what the user needs to know, no more and no less, and that's a list of instructions. In this case, it's driving directions. Yes, there is a simplified map that's also provided, but that's a backup to the verbal directions in case the driver wants more clarification. So let's review how the navigation system demonstrates the application of these best practices. The expert knowledge, which started out as a 2D map, is stored in a database composed of junctions and roads, and computer code that contains the routing algorithms. It stays in that form until it gets instructions from the driver to calculate a route to a destination. It uses this goal and the context provided by the GPS reading of the current location to calculate all possible routes. It then uses traffic conditions and knowledge of the driver's preferences to select the best route. These two steps are the pruning process in action. Finally, it delivers the solution to the driver in the simplest form possible, a list of driving directions. If the context changes because the driver leaves the designated route, the system recalculates. It reprunes and updates the list of directions. Because navigation systems are such good examples of knowledge-shaping best practices, they've become indispensable to drivers who need to navigate unfamiliar routes. If only all of our knowledge artifacts were so effective. In fact, this is where I believe a great opportunity lies. We need to apply these best practices to many other forms of knowledge. The idea of documenting expert knowledge in all of its complexity, then simplifying based on context, and delivering the results simply and elegantly to the user, has applications far beyond vehicle navigation. The problem is that it took companies like Garmin years of effort and large staffs of people to develop today's navigation systems. How do we duplicate that process for the kinds of knowledge held by individuals and small organizations? That knowledge is important too. Part 2 of this presentation is about automating these best practices so that people with valuable knowledge can create applications that embody their expertise. Speaking of knowledge shapes, I thought you'd be interested in knowing the shape of this particular note of fact, my presentation about the shape of knowledge. This presentation was created using Prezi, a wonderful visual presentation environment. And my Prezi is actually a tree, this tree. When I was developing my story, I started by decomposing my basic message that understanding the shape of knowledge is key to unleashing the knowledge economy. I decided to break my story up into 2 major components. The first part would focus on the conceptual foundation of my thinking. That part of the story covers 3 major ideas. Knowledge is structured information, knowledge is transmitted through knowledge artifacts, and certain shapes are better for certain types of knowledge. Each of these ideas is further decomposed into more detailed slides. The second part of my story is about the application of these concepts. This part of the story is broken down into the existence of best practices and how to automate these best practices, which is my topic in part 2 of this video. Prezi lets me build and visualize my presentation in a way that reflects my actual thought process. Just as you would begin any piece of expository writing by creating an outline, which is of course a text-based tree, decomposing an argument or a presentation is a great way to ensure that your thinking is logical and complete. But when you present your argument, you can only do it one bit at a time. Prezi requires that you build a path through your visuals, and that's what we've been seeing, is that linear path. So this presentation in itself has been an example of our knowledge shaping best practices. My expert knowledge was developed and documented using a tree. It's a composition model that depicts my argument for the importance of knowledge shaping. This particular video, however, focuses only on the conceptual foundation and best practices, so I've pruned away the section that covers implementation. Most importantly, the communication of the knowledge is being done in the simplest shape possible, a linear path of slides that captures my storyline. If you're interested in learning more about the shape of knowledge, you can read my ebook on the topic or visit our website at www.apprenticesystems.com to see how we use these ideas to build applications that provide real-world solutions. The shape of knowledge provides a mental framework for others to modify and challenge. If it encourages people to see knowledge artifacts in a new and different way, or to ask questions they might not have asked before, I will have accomplished my goals as a knowledge author.